Hello everyone, today we will present the Lab 1 report presentation with the title Transfer Function and System Response. We are Eng Man Ling, Guan Wei and Hui Jia.
I will present about the calculations. For Part A mechanical system, M1 and M2 is the masses, K1 and K2 is the spring, FV2 is the damper coefficients, FV1 and FV3 is the coefficients of frictions, while the Ft is the force applied to the mechanical system. There are two equations that can obtain from this system, which are for M1 and M2. This is the equation for M1, and this is the equations for M2. Then we will transform the equations into the matrix form. This is the matrix form for our system. To find the x1, we need to use the A1 in matrix form by replace the first column with 0 and Fs. And to find the x2, we will use the A2 in matrix form, which will change the second column with 0 and Fs. Then we will find the determinants A, A1, and A2. This is the equations for determinant A. And this is the equations for determinant A1. And the last one is the determinant A2. This is the equations for the determinant of A2. Then we will find the transfer function G1s, which is equal to S1s over Fs. To find the S1s is equal to determinant of A1 divided by the determinant of A. This is the equations for G1s. To find the transfer functions of G2s is equal to S2s over Fs. To find the S2s is equal to determinant A2 divided by the determinant of A. Hence, we will get the G2s is equal to these equations. Then we will set the system parameters as below. M1 and M2 is equal to 1, K1, K2 equal to 1, FV1 equal to 2, and the FV3, FV2 is equal to 1. By substitute the parameter into the transfer function G1s, and we can get the equations as s plus 1 divided by the s power of 4 plus 5 s power of 3 plus 8 s power of 2 plus 5s plus 1. Then to find by substituting the parameter into the transfer function G2s, and we can get the G2s equal to s power of 2 plus 3s plus 2 divided by the s power of 4 plus 5s power of 3 plus 8s power of 2 plus 5s plus 1. The transfer functions G1s and G2s will use in the MATLAB. That's all from me. Thank you.
This is the Part B electrical network calculation. The circuit is redrawn as shown at here. The resistor 1 is series with the capacitor 1. Resistor 3 is series with inductor and parallel with the resistor 2 and capacitor 2. By applying the mesh analysis and using the Kirchhoff law, the mesh 1 at the loop 1 is right at here, the equation, and the equation for the loop 2 mesh 2 is right at here. So we arrange both equation in matrix form as shown at here. To find the determinant A and A2, the equation is calculated using the matrix loop, and we get the answer. For the A2, the answer is calculated, which is Vs multiplied with R2 plus 1 over C2. To find the current at the loop 2, I2, which is equal to determinant A2 over determinant A. The equation is right as here by substitution. And the output voltage at the inductor VL is equal to I2 plus I2 multiplied with Ls. And here we can find the transfer function, which is the VL over Vs by using the substitution method. The parameters of the circuit is set as below, which is resistor 1 equal to 1 ohm, capacitor 1 equal to 1 farad, resistor 2 equal to 1 ohm, capacitor 2 equal to 1 farad, resistor 3 equal to 1 ohm, and the last inductor equal to 1 Henry. This value is substituted in the transfer function VL over Vs, and we can get the answer. Final answer is s power of 3 plus s power of 2 divided by 2s power of 3 plus 5s power of 2 plus 4s plus 1.
Good morning, Doctor. My name is Guan Wei, and I will be taking over the MATLAB presentation part. So here we can see, at first we're going to declare all these variables, and because for the mass, for the spring, and also for the friction force, and since the lecture has already provided all the values in it, so we just have to put all the values into as for each one of them as they are given in the lab sheet. So next up we're going to declare the S and Fs first, because these two will be remained unchanged in the throughout this whole running. So, but in order to maintain these two, we will have to put the code schemes as YMS. And then here, just simply, since to find the normal determinant, we just simply have to take the equation take the matrix form of the answer from the calculation part and paste it here. So here we can see the A is equivalent to M1 S squared plus F2 multiplied with the S and so on. And here there's the catch. Because in the calculation part, you can actually basically write down the matrix form in the 2 times 2 versions. But in this calculating part, we have to put the same column here in order to break it into the 2 times 2 column. So in order to find the x1, to find the value for the x1, simply have to use this one. Here we can see A1 is used to find the x1 over fs later. So for the A1, which is also for the x1, because this is just to find the determinant for the x1. So here we just simply have to put the 0 fs in front of it, because this is how the matrix is supposed to be and how it works. And just simply do the 2 times 2, again, 2 times multiplication and the calculation of the matrix rules. And the same goes for the determinant of the A1. And sorry to add on lately. But then for the A2, the same goes to the A2 as well, which is also to find the determinant for the x2. But in this A2, the 0 fs will be put in the second column here. For the x1 determinant for the x1, we're going to see the 0 fs is located at the first column in the first matrix. So here, in order to find out the final transfer function for the x1, x2, simply have to just use the determinant for the x1, ax1 divided by the normal determinant, and then the same goes to the x2, using the determinant of the x2 divided by the determinant of the normal matrix form. And then to draw the figure out, and also to find out all the values of the numerators and the denominators in the transfer function of the x1 and x2. So basically, because from the x1 here down here, we already have found that the x, it is fs multiplied with s plus 1. So s plus 1 here, why from the numerator for the x1 it is only 1, because there is no value in front of the s and also the 1. But if the value of the 1 is changed into 4 or something, then it will have to be changed into 1 4. But in this case we only have 1, so basically just 1 and 1. And then same goes to the denominator part. S multiplied, s to the power 4 only has, there's no value multiplying in front of it, and because it's only 1. And then there's 5 here, so that is actually this 5, and then this 8 here is also actually this 8. And the same goes. And then to do the transfer function, we basically just do put this code TF for the numerator and also for the denominator. In order to maintain the value, we simply just put the sys x1f, because this x1f will actually be the variable to store the transfer function from this. And then to get the figure of it, we basically just put the figure 1 and then step to produce the graph. We put in the code step sys x1f and then grid on to make everything more tidier. And the same step goes to the x2, the transfer function of the x2. And then lastly, since the lab sheet requires us to combine this together, we just simply put this together by putting the code step as sys x1f and also sys x2f, by putting the value of the transfer function of the x1 and x2 together, and also and before putting them together, we need to create a graph for them to be together, for them to be put together. Now for the first transfer function, which we can see here for the x1, here is the output graph, as we can see here. And then we're going to rerun everything again, just to make sure everything is smooth and also correct as the way we want it. For the first one, it's going to be this normal thing for the figure 1. And then for the figure 2, we're going to have this thing again, which is for the x2. And then after that, in the end, since the question requires us to find the combination of this two-step unit step response graph. So all you have to do is just, like I said before, put the step and put this variables together, and then we can get this. So this is how it's going to look like. Now for the lab 2, part 2, since it's only the electrical network, so we're gonna and also all values have been already given, or we just assume the value if there's no value in it. So all values given or the values assumed will be only 1 in order to simplify, to make everything simple, in a simple way to understand. So as usual, we declare 2, this 2, the S and also the BS, as the something that should be changed or adjustable during the whole running of the system. Then from the first equation, we're going to get the A, which is the same thing for the normal matrix. We're going to get the R1 plus R2 plus R plus R1 divided by the C1S plus 1 or C2S. Then same, we can basically just get all this matrix from calculation part and put it here, and don't forget to put the semicolon to break it into the same row to get the 2 times 2 matrix form. And then, so since we're only required to find A2, which is also the X2, so everything will be much more simpler rather than having another one, which is also like the previous lab. The previous lab has the X1 and X2. For this case, in this case, we only have the X2 or the so-called A2. So for the A2 here, and same thing will happen again. The S and the 0 will be on the second column here to do the multiplication of the formula of the matrix. And then to find the determinant and to find the final answer for the I2, all we have to do is to use the determinant of the A2 to be divided by the determinant of the A of the normal matrix. So since VL is equivalent to I2 multiplied with LS, therefore VLS is basically equivalent to I2S. So after we found out, let's just rewrite everything in. After we find out the value of this, as you can see here, the value here. Since we only have 2 values here, so therefore it's going to be 1100, 1100. Since this is S cubed and this is the S squared for the normal S and also for the normal integer, there isn't any numbers over there, so basically just put them 0, 0. And then for the denominator part, we can see there is 2 on the S cubed, 5 on the S squared, 4 on the S, and 1 on the integer. So basically just the same as the previous and that's lab. It's basically just copy paste everything here, and to do the transfer function, we just put TF, which stands for the transfer function for the code, bracket numerator and also the denominator, then closing bracket. And then we're going to put the value into the sys VL. And then to do the basic response, we're going to put the code step SYS VL again. And then to make everything tidy, we're going to put the grid on. And here's how it's going to look like through the graph.